Alright guys, so this is our second video for our Flip the Classroom lesson, introducing conic sections, focusing on parabolas. And in this video, we are going to talk about orientating parabolas on the XY axis with vertices at the origin. And we're going to be talking about these parabolas as conic sections. So we really want to think about these parabolas more as shapes than as polynomials or even functions. In general, in the last video, we said that we can define a parabola with its vertex at the origin, vertically orientated, with the equation x squared equals 4py. And in this video, we're going to define that length p as the focal length. And it's always going to be the distance from the vertex to the focus. So right here on our graph, we've got that length p as the distance from the vertex to the focus. And right here, that allows us to define the focus with the order pair 0, p. We know that the vertex has to be equidistant from the focus and the directrix. So right here, we know that the directrix is going to be that distance p in the opposite direction, which gives us the equation for the horizontal line of the directrix as y equals negative p. So right here, we've got our focus and our directrix defined both with that focal length of p. And we've got two more new terms to define. We're going to say that the focal axis is the line that goes through the focus and the vertex. So right here, our focal axis, in this case, is basically the y-axis, which we can define as the vertical line x equals 0. And we're going to say that the focal width is going to be the width of the parabola through the focus. Now, right here, we can sort of take note that the ordered pairs on either end of our focal width, if we've got our focus as 0p, are going to be of the form x, p, and negative x, p. So basically what we're seeing is this length x is really going to be half of the length of the focal width, which is going to be the distance across the entire parabola. So right here, what we can do is plug in a y value of p into our equation and define that length right there from the origin out x on the x-axis. So right here, what we're going to say is we've got x squared equals 4p times p, the y value of p, that is. And right here, that'll give us x squared equals 4p squared. Now we can take the square root of both sides, and that's going to give us x equals plus or minus 2p. Now, right here, this length is going to be the positive 2p, and this length is going to be the negative 2p. In general, what we can see here is that that gives us this length right here, 2p, as being half of the focal width. And so the entire focal width is going to be a length of 4p. And in general, what we say is the focal width is always going to be positive. So what we're going to do is define the focal width as the absolute value of 4p. Now, at this point, what we want to do is talk a little bit about how our vertically orientated parabola with its vertex at the origin is opening. Right here, what we have on the left side is our parabola opening up. And right here, what we can say for our parabola opening up is the distance from the vertex to the focus is going to be a positive p in this case. So right here, in general, whenever we see a parabola opening up, we want to take note that p is positive. To the right, we have a parabola opening down. And now if we look at that distance from the vertex to the focus, we can see that we have a length of negative p. And so right here, with a parabola opening down, we want to take note that p is, write this a little more legibly, p is negative. Now, whether p is a positive length or a negative length, what we're going to say is that the way we've defined our equation, our focal axis, our focus, our directrix, and our focal width is going to be the same. right? So basically what we're going to see is a varying of that p-value as being either positive or negative, determining the equation and the focus and the directrix. Now, we can see this in our next example where we're asked to find and graph the focus, directrix, and focal width of our parabola. Right here, what we can say is since we have a vertically orientated parabola, we know it can be represented by equation of the form x squared equals 4py. And at this point, what we can say is, all right, well, we know that the focus and directrix and the focal width are all defined by that value p, that focal length. So right here we can determine that focal length if we can plug in one x in value on our parabola. And right here we can see that our parabola goes through the ordered pair 2, -2. So right here we can plug in the x value of 2 and the y value of -2 into our equation and determine that p-value. So right here we're going to have 2 squared equals 4p times -2, and that gives us 4 equals -8p. And when we divide by that -8 on both sides, we get a p-value of -1/2. So with a p-value of -1/2, we can determine first the focus, and we can say that our focus is then going to be right here 0, -1/2. And right here, that's what we're seeing over here. Again, right here, we want to think that, as a parabola is defined by all points that are equidistant from the focus and the directrix, we should have our parabola sort of opening around that focus. And so right here, we're seeing our focus as 0, -1/2, and that should make some sense to us. We can say that, again, the vertex is going to be halfway between the focus and the directrix. So again, that p-value in the opposite direction is going to give us the directrix. And if we look up here at our definition of the directrix, we say the directrix is y equals -p. So if we say y equals a -1/2, we can also think about that as y equals +1/2, right? And that also makes sense because the directrix should be on the other side of the vertex from the focus. And right here, finally, we can say, got our directrix as y equals 1/2. We can say that the focal width is going to be defined by our equation right here, the absolute value of 4p. And so right here, the absolute value of 4p is going to be the absolute value of 4 times our -1/2. And that's going to give us 2. And if we were to plot that focal width, or the width of the parabola through the focus, we can see that actually that focal width is approximately a length of 2. Now, on top of all this, we can come up with an equation for our parabola, right, in standard form, as we define it for our conic section, as basically being x squared equals 4 times the p-value. So with a p-value of -1/2, we can call this -2y. And that's going to be the standard form of the equation defining the parabola as a conic section on the xy axis. If we have a parabola with its vertex at the origin horizontally orientated, we're going to say that it's going to be defined by the equation y squared equals 4px. And right here, we could go back and sort of prove this definition of our horizontally orientated parabola, but we're just going to sort of take it for granted. The other thing we can sort of see is our vertically orientated parabola is basically symmetric with the y-axis, and that's x squared. And right here, if we're talking about a parabola symmetric with respect to the x-axis, that of course would be defined by y squared. So it should make sense to us when we see it. Now right here, what we're going to say is the focal length is going to be defined in that same way. So that's always going to be the distance from the vertex to the focus. And right here, for our horizontally orientated parabola to our left, we can see that p-value giving us the focus as the ordered pair p0. Right here, the directrix is going to be that same length p, but in the opposite direction. So right here, if we go p in the opposite direction, we can say that our directrix is going to be the vertical line, x equals -p. Right here, we're going to define the focal axis, again, as that line that goes through the vertex and the focus. And so right here in this case, we're going to say the focal axis is y equals 0, right, which is basically the x-axis. And again, the focal width we're going to define in that same way. So that's going to be the width of the parabola through the focus. And in this case, we can say that that's going to be, again, that absolute value of 4p. Now right here, just like we saw up top, if we have a parabola opening on the positive x-axis, we're going to see that p-value, or the distance from the vertex to the focus, is going to be a positive p. So right here we want to take note again, p is positive when we're opening on the positive x-axis for a horizontally orientated parabola with its vertex at the origin. If we are opening on the negative x-axis, then basically what we're going to say is that distance from the vertex to the focus is a negative value. So right here we've got a negative p. And right here, we want to again take note, p is negative in this case, right? Now right here, basically, again, what we're going to say is that all of our definitions hold for a horizontal oriented parabola with its vertex at the origin, whether our p is positive or negative. And basically what we'll see flush out is that negative p-value is going to change where the focus and the directrix are on the xy axis. If we're talking about that length as being a negative p, then of course there's our focus point, and we would see that order pair as negative p, 0, right? With our directrix as x equals a positive p. And right here what we can see is that with a positive p, we've got the focus as positive p, 0, and our directrix is x equals a negative p. Now right here what we have is a problem a lot like the last problem, where we're asked to graph the focus, directrix, and focal width of the parabola. And what I'm going to ask you guys to do is to go ahead and give this a shot on your own. Since this is a horizontally orientated parabola with its vertex at the origin, we know it can be defined by the equation y squared equals 4px. So right here, what I want you guys to go ahead and do is to define that p-value with an ordered pair on the parabola. So by taking an ordered pair on the parabola and plugging it into this equation, we can solve for p. Right here we can say this ordered pair is 2, 4. And then we're going to use that p-value to define the focus, directrix, and focal width. And then we want to graph those as well. So I'm going to pause the video right now and let you guys give this a shot. All right, so right here, if we plug in that ordered pair 2, 4 and solve for p, we get a p-value of 2. So right here, that means we're going to go 2 out from the vertex on the positive x-axis to define our focus. And we'll go 2 back to define the directrix as x equals negative 2. We'll say the focal width is going to be the absolute value of 4p, so that's the absolute value of 4 times 2, which gives us 8. And if we graph this, we can see that that is the width of the parabola through the focus. If we were to define an equation for this parabola, we could say that we could get that equation by plugging in the p-value into our equation. So right here we've got y squared equals 4 times 2, or 8x, would give us the standard form of the parabola as a conic section on the xy axis. All right, guys, so that's this video. We will look at parabolas on the xy axis with vertexes other than the origin in the next video. And we're going to call this lesson 3 videos long. So right here, we'll see you guys in the next video, and we'll look at that stuff there.